Hello Math 1093, this is Dr. P with the first in a sequence of videos that I wanted to make about some exam questions from this semester that I thought would be good things to review prior to the extra life tests and the final. So in this video we're going to talk about question 4 from the first midterm. This is that notorious question where I gave you a graph of a trig function and you had to come up with a formula that creates that graph. Alright. So in this video I want to talk about a couple of different ways of thinking about this. One of them is a transformational approach. In other words, we're going to talk about how to get this graph from the standard sinusoidal graph using transformations. And then number 2 is more of a formula-based approach. Okay, now realistically, you're probably going to want to know the formula-based approach. The transformational approach takes a while to think through. But there is a connection between these two. The transformational approach is how we get the formula-based approach. And I want you to understand both things. All right, so the thing I'm going to start by doing is I'm going to plot a standard sinusoidal function in this graphing window just so that we have it for reference. And because I find the cosine function a little bit easier to use as a base for this type of problem, I'm going to use the cosine function. Alright, so the cosine function starts at 0, 1, and then hits the t-axis, let's call that the t-axis, at pi halves, comma 0. What would that be? It's about 1.57, so about right there. And then goes through pi, comma negative 1, so around there. It's probably a little bit further to the right than I should be. And then comes back to the t-axis at 3 pi over 2. So what would that be? That's about 4.6 something. And then completes a period at 2 pi. So around there. Okay, so that is one full period of the standard cosine function, give or take. Okay, and I wanted to have that up here. Okay, now the rest of this I'm really just guessing it, where things should cross, but that seems about right. I wanted to have that up here so that we could think about what transformations need to be done to this graph in order to create the graph that I want, which is this graph here, this one. Woo! Okay, so what transformations do I need to do? Okay, and usually there are going to be 4 or 5 things. The things that I might need to do, well, first of all, I might need to reshape the graph. So I might need to stretch the graph or compress it horizontally in order to get the right period. Okay. I might also need to stretch or compress vertically in order to get the right amplitude. In order to account for the amplitude. Sorry, my penmanship is getting worse and worse. Okay, number 3, I might need to move the graph or shift it horizontally. That would be a phase shift. Number 4, I might need to shift vertically in order to get the right midline. And finally, I might need to do a reflection, or I might not. It's just something we'll have to work out when we get there. Okay, so first of all, what do I need to be thinking about as I do each of these? Well, I need to figure out what my period needs to be, what my amplitude needs to be, and so on. Let's work out the period first. As I go along the graph from 3.2, 4 to 3.8, 6.2, that is 1/4 of a full period there. Actually, let's use this as our starting point since we're using a cosine function. Okay, so that's 1/4 of a period, and then this is another 1/4, and this is another 1/4, and this is one more 1/4. That makes one full period. See that red part there? Let me go over with my little spotlight thingy. This is one full period, and this piece here, this 1/4 of it, goes from 3.2 to 3.8. So the period of this function, I could actually write down the coordinate at this point. It's going to be 5.6 comma something. I think it's going to be 5.6 comma 4, right? So a full period is 2.4. So I need to take the period of the standard function, this one here. I need to stretch or compress so the period goes from 2 pi to 2.4. So that's going to involve multiplying the t in my formula by 2 pi over 2.4. Okay, these are just things I'm going to think about later. All right, what about the amplitude? Well, the amplitude should run from the midline of the function, so this thing, to the top or bottom of the wave. The top of the wave is right here, and that height is 6.2. The midline of the wave is at y equals 4. So my amplitude needs to go from being 1, that's the original graph, to 2.2. So I'm going to multiply my entire function value by 2.2 in order to create that vertical stretch. All right, what about the horizontal shift? If I'm using my cosine function as a base, then I want to shift this so that this point here moves over to a known high point of this function. Well, that known high point is at 3.8. So I think I want to take this point and move it over by 3.8. So I need to move to the right by 3.8. That's going to involve replacing t with t minus 3.8 in parentheses. That is, I need to replace t with this entire thing here. All right, what about vertical shift? Well, my midline needs to go from 0, that's the midline for this function, is y equals 0, to y equals 4. So I need to go up by 4 units. So that means I need to add 4 to the function value. All right. And if I do all of that, I think I will probably not need a reflection, because I will have taken this point here, this point, moved it over to 3.8, stretched vertically, compressed the whole thing. I really would have compressed the whole thing earlier. Moved up, and I think that the top of my wave is where I need it to be. I don't need to flip it upside down across the midline or anything. So I think no reflection is needed. If you did it differently, you might need a reflection. But under this method, I don't think I need one. All right, so I think I'm about ready to start transforming my formula. Now remember, the base graph I'm working with, the base function I'm using, is the cosine function. I could have used a sine as well. I chose to use a cosine just because I find that starting point a little bit easier to work with. I find it easier to identify the top point of the graph. All right, so g of t is cosine of t. And now I'm going to apply these transformations, the ones in this list, one by one. All right, so first I'm going to replace t. I'm just going to put a little subscript there to indicate which step I'm on. I'm going to replace t with 2 pi over 2.4 times t. Okay, so just as a check that this is working in a sensible way, what happens if I put t equals 2.4 in here? Like, I know that if t is 0, this whole thing is 0, and I get a top point of this graph. If I put t equals 2.4, that cancels out this 2.4, and I'm left with cosine of 2 pi. That's like one full period. So that's the way I want this to work out, is where a full period is 2.4 in the t variable. Okay, what about g2 of t? I'm going to multiply the whole thing by 2.2 in order to give me that vertical stretch. I don't know why I put cosine in parentheses. I didn't need to. It's not bad that I did. Okay, let's just write it this way. 2.2 cosine of 2 pi over 2.4 t. There we go. Now I feel better. All right, so that's step 2. Now I've taken this and I've stretched it out by a factor of 2.2, making the amplitude not 1 but 2.2. All right, g3. I need to perform a phase shift. So I'm going to replace t in my formula. Now there I go again. 2.2 cosine 2 pi over 2.4 t minus 3.8. Now you may wonder, why minus 3.8 and why in parentheses? But this works perfectly, because if I let t equal 3.8, then I get 0 here, which means I'm taking the cosine of 0. And when I take cosine of 0, that's my maximum value of the cosine function. So that means t equals 3.8 will give me a top point of this wave. So that means I'm on the right track. And finally, g4, I'm going to apply vertical shift, take this whole thing, 2.2 cosine 2 pi over 2.4 t minus 3.8, and add 4 to the whole thing. All right, so now if I substitute in 3.8, what do I get? I get 0 here, which means I got 2.2 times the cosine of 0. Cosine of 0 is 1, so that's 2.2 times 1. Let me write this down. 2.2 cosine of 0 plus 4. This is when t is 3.8. And that is 2.2 times 1 plus 4, 1. And that is 6.2. And that's exactly what I wanted here, 3.8 comma 6.2. That's a check that this thing is working the way I want. So I think if I were to give this as my function formula, this for f of t, I think that would be full marks for that question. All right. So anyway, that came together kind of gradually, one might say slowly. But let's talk about a quicker way of getting there. The quicker way is to know the following formula, which has all of the parts that we just did. Let's see, how do I want to do this? I'm just going to shrink this a bit so I have a little more room to write. So in general, the formula is going to look something like this. F of t equals a times cosine or sine, you can use either one in most cases, of k times t minus c plus b. And what are the things in this formula represent? A is the amplitude. That's the distance from the midline to the top or bottom of the wave. Okay. And then this k, 2 pi over k, is the period. Or alternatively, if you like, you can rearrange this using algebra and get the k is equal to 2 pi over the period. Those equations both mean the same thing. Okay, that's just using algebra there. Okay, what else? That c represents the phase shift. But notice that it is being subtracted and it's in parentheses. That's because if I want to perform a horizontal shift on a function, I need to replace that t with the quantity t minus c, where c is the amount to the right that I want to translate. If I want to go to the left, then let c be a negative number, then subtracting that gives an addition here. And finally, what else? Oh yeah, b. Y equals b is the midline. Okay, so if you can learn all of those components, oh, and by the way, if you do need to do a reflection over the midline, then attaching a negative sign to this will do the trick. But if you organize things right, if you're trying to do a formula finding problem, organizing things right will keep you from having to do that. So anyway, if you can learn these 4 components and learn what they have to do with this formula here, in particular, one stumbling block for a lot of people was just not realizing that this number is not the period. It has to do with the period, but it's not the period. The period is 2 pi divided by that number, and that was borne out here. If I wanted a period of 2.4, then I need to organize this so that multiplying this number by 2.4 gives 2 pi, and that's why this formula works. And then the rest is a little more straightforward. You have to remember a couple of things about how this gets incorporated. But what I would suggest on this is do a few practice problems. There's a few on my math lab. There's the other version of this exam, if that exists somewhere out there. And there were several problems I gave on Team Homework 3. Let me write that down. Team Homework 3 for more practice. And you know, if you run out of stuff to do there, you can always just say, hey, give me a sinusoidal wave. I'll find a formula for it. You can always do that. Any sinusoid that you come up with here will have to have some formula, assuming it's a good sinusoid. Okay, so that's the end of that video. More to come.